Have you ever wondered if there's more to Mars than meets the eye? What if signs of life, ancient life, could be hidden beneath its red surface? Mars, the fourth planet from the Sun, has been the subject of human fascination for centuries. But recent discoveries from the Perseverance rover have raised more questions than answers. In 2021, the Perseverance rover made a historic landing on the Jezero Crater, a vast impact crater on Mars. But why here? Why Jezero? What made scientists so excited about this particular spot? The answer lies in the ancient river delta that once flowed through this crater and the lake that existed long before Mars became the barren world we know today. The rover, with its advanced tools and instruments, has been digging into the sediments of what was once a lake bed. This discovery is crucial because water is a key ingredient for life as we know it. But there's more. As Perseverance scours the landscape, it has uncovered what could be ancient signs of life, not life as we know it, but microbial life that could have once thrived in Mars' early history. Before we continue, make sure you subscribe, like the video so you can stay up to date on all the latest mysterious space discoveries. So, how did scientists determine that this was once a lake? It's not just the appearance of the terrain. If you look closely, you can see the subtle signs of river channels, the delta formations, and the spread of ancient sediments. This is a clear indication that water once flowed here, creating an environment that could have supported life. But what was the nature of this life? Was it similar to the earliest forms of life on Earth? Could Mars have harbored microbial life billions of years ago? Perseverance has uncovered mineral deposits that only form in the presence of water. But does this mean life was there? As the Perseverance rover continues its exploration of Bright Angel, a part of the ancient lakebed, it has unearthed some fascinating discoveries. The rover has found sedimentary rocks that show signs of interaction with water, and inside these rocks, it found something even more intriguing: small nodules. These nodules, often compared to leopard spots or poppy seeds, are not just random formations. They bear a striking resemblance to patterns that are often seen on Earth, in places where microbial life was present. These microbial patterns could be the key to understanding whether life ever existed on Mars. On Earth, calcium sulfate is often associated with the presence of water and microbial action. This mineral composition is a strong clue that these tiny specks might be evidence of past microbial activity. But what does this really mean? Could these be the fossilized remains of ancient microbes? Or could they be the result of some other non-biological process? One of the most important discoveries here is the evidence of organic compounds. These organic molecules, which are the building blocks of life, have been identified in the Martian rocks. While these compounds could have formed through chemical reactions from volcanic activity or other non-biological sources, the fact that they were found alongside the microbial patterns makes them even more intriguing. What makes this discovery even more fascinating is the temperature of Mars. Unlike Earth, which has areas where these compounds can form in high temperatures, Mars is far colder. If these formations were caused by extreme heat, we would see large crystals in the rocks, the kind you only find after intense heating and cooling. But that's not what Perseverance found. Instead, the low temperatures and the patterns suggest that something else is at play, perhaps microbial life from billions of years ago. With these discoveries, the case for past microbial life on Mars is becoming stronger. But we're not there yet. While Perseverance has found key clues like organic compounds and microbial patterns, we still need more evidence to say, definitively, that life ever existed on the red planet. But here's the exciting part. Perseverance hasn't just been observing Mars, it's been collecting samples. That's right, samples that are now sitting on Mars, waiting to be returned to Earth. This is where the Mars Sample Return mission comes into play. The samples that Perseverance has gathered could be the key to solving the mystery once and for all. They'll be analyzed in advanced labs here on Earth, using the latest technology to search for even more evidence of life. But here's the catch. The future of the Mars Sample Return mission is uncertain. Under the current White House administration, plans to return these samples to Earth have been delayed. While NASA and other space agencies remain determined, the uncertainty has led to frustration among scientists eager to get their hands on these samples. And that's not all. The Chinese Space Agency has its own Mars Sample Return mission in the works, and they're planning to target the same rock that Perseverance has been studying. Could this competition lead to breakthroughs, or will it delay the answers we're all waiting for? The samples collected by Perseverance are a treasure trove of potential discoveries, and the possibility that they could hold the key to unlocking the secret of past life on Mars is something no scientist can ignore. Until these samples are brought back to Earth, we're left with a puzzle. Could Mars have harbored life billions of years ago? The evidence is compelling, but we still need that final piece of the puzzle. This is the stage we're at right now. The answers are tantalizingly close, but they're not within our reach just yet. Now let's step back for a moment and think about the bigger picture. Mars wasn't always the barren desert we see today. Billions of years ago, it had a very different climate. Imagine this, a planet once filled with water, with lakes and rivers that could have supported life. It's not as crazy as it sounds, especially when we look at the geological features that Perseverance is uncovering. River deltas and lake beds are signs of a more hospitable Mars, a planet that could have hosted early microbial life. Scientists believe that Mars' habitable period might have lasted for hundreds of millions of years. In that time, the planet might have had all the conditions necessary for life to thrive: water, organic molecules, and energy sources. But something went wrong. Mars's atmosphere began to thin, and the once thriving lakes and rivers dried up. The planet's surface became hostile, and any trace of life vanished. But was it truly gone? What if there are still traces of life buried beneath the surface? Could microbial life have survived in some form, hidden away in the deepest cracks of Mars's landscape? The answer might lie in the samples Perseverance has collected. But as we wait for those samples to come back to Earth, we can't help but wonder, what secrets are still buried on Mars? Mars's ancient past is a mystery that scientists are still trying to piece together. Each new discovery adds more to the puzzle. What did Mars look like when it was full of water? Could it have been an early home to microbial life? These are the kinds of questions that will shape the future of space exploration. As we look at Mars, we can't help but wonder, if life could exist there in the past, could it exist elsewhere in our solar system or beyond? The Perseverance rover is just one piece of a much larger puzzle, a global effort to find life beyond Earth. For decades, scientists have speculated about the possibility of microbial life on other planets and moons, and the findings from Mars are helping shape this search for life across the universe. Mars is not the only place where scientists are looking for signs of life. Europa, one of Jupiter's moons, and Enceladus, a moon of Saturn, both have subsurface oceans beneath their icy crusts. These moons are prime candidates in the search for extraterrestrial life. Europa, for example, might have a deep ocean that is in contact with a rocky core, which could provide the necessary conditions for life to flourish. But just like with Mars, we need samples to confirm the possibility of life on these distant worlds. Could these moons hold secrets just like Mars? What if life, or the building blocks of life, are more common in our solar system than we ever imagined? As we develop the technology to send missions to these moons, the possibility of discovering life just beyond Earth seems more likely than ever. Even farther beyond, exoplanets and other star systems are now part of the search. James Webb Space Telescope has already started examining some of these planets, and the first signs are promising. Some of these exoplanets are in their star's habitable zone, where liquid water could exist on their surfaces. Could these distant worlds be home to life as we know it, or something completely different? The question on everyone's mind, will we ever find definitive proof of life beyond Earth? After decades of searching and thousands of missions, we still haven't discovered clear evidence of life elsewhere. But the findings from Mars have given us hope. The Perseverance rover's discoveries, the minerals, the organic compounds, the microbial patterns, have put us closer than ever to answering this question. But we're not there yet. There's a key issue standing in our way: the lack of direct evidence. What we have are clues, tantalizing hints that life once existed on Mars, or that conditions there were suitable for life. But clues are not proof. While the organic compounds found by Perseverance are intriguing, they don't necessarily point to life. These compounds can form in a variety of ways, both biological and non-biological. What will it take to get that proof? The samples Perseverance has collected could hold the answers, but we won't know for sure until we can study them here on Earth in our advanced laboratories. The Mars Sample Return mission is the next step, but it's not set to launch for several years. Until then, we wait. And even when we do get those samples, we may face a new set of challenges. Will the technology on Earth be able to detect life in these ancient rocks? Could microbes, if they ever existed, have left behind enough evidence to identify them after billions of years? The challenge is enormous, but that's part of what makes this journey so exciting. Every discovery, every step, brings us closer to the answers we seek. So, what comes next in the search for life on Mars? The Perseverance rover has already provided us with invaluable clues, but there's much more to be done. While we eagerly await the Mars sample return mission, there are still plenty of unanswered questions. What else could Perseverance discover in the coming years? What hidden secrets might lie beneath the surface of Mars? The rover is not done yet. In the coming years, Mars exploration will only get more advanced. New rovers and landers will be sent to different areas of the planet to continue the search for life. The goal is not just to find microbial life, but to understand the history of Mars itself, how it transitioned from a potentially habitable planet to the dry, cold world we see today. What happened to Mars? Why did it lose its ability to support life? These are the questions that will guide the next generation of missions. The Mars sample return mission may finally give us the definitive answers, but it's also part of a larger goal: preparing for human missions to Mars. What if we're not just finding evidence of past life, but preparing for future human life on Mars? The technology being developed now for Mars exploration will lay the groundwork for the first human mission to the Red Planet. Sending humans to Mars is still decades away, but every mission, every rover, and every discovery brings us closer to that goal. Imagine walking on Mars, breathing in its thin atmosphere, and standing on the ground where ancient life once may have thrived. It's an exciting prospect, and it's becoming more possible with each passing year. As we look at Mars, the questions keep coming. Are we alone in the universe? Mars is just one world, one possibility in the vast expanse of space. If life could exist there, could it exist elsewhere in the universe? Mars is our closest neighbor, but there are billions of planets orbiting stars far beyond our reach, planets in the habitable zone where life could possibly exist. With the discovery of exoplanets, planets outside our solar system, the possibility of life beyond Earth is no longer a fantasy. James Webb Space Telescope is currently studying distant planets, trying to detect the signs of atmospheres and water that could support life. But just like with Mars, it will take time and technology to confirm if any of these exoplanets are truly habitable. Could one of these planets harbor life? Could we someday discover another civilization, just like our own? These questions are driving the next wave of exploration, and while we haven't found definitive proof of life yet, we're closer than ever. The search for life is not just about Mars. It's about exploring the universe and understanding our place in it. Mars is just the beginning. As we continue to explore other planets and moons, we will eventually answer one of humanity's most profound questions. Are we alone? For now, we wait for the samples from Mars to return to Earth, and as we do, we keep exploring, keep searching. The future of space exploration is filled with endless possibilities, and each new discovery, no matter how small, brings us one step closer to the truth. Do you think Mars once supported life? Or is it just another mystery waiting to be solved? Let us know your thoughts in the comments below. And don't forget to subscribe for more exciting space discoveries and updates. Keep exploring with us.